question number 3 about nitrogen and phosphorus compounds. So nitrogen and phosphorus, as we know, are elements in group number 15 of the periodic table. And the question is, nitrogen is found in organic compounds such as nitrogen oxide, NOx is the number of oxygen, nitrate, and nitric acid. Identify one natural and one man-made occurrence of nitrogen oxides in the atmosphere. Okay, so the natural one, I can say it's produced by natural way by lightning or by sunlight. So like what, like NO or NO2. Okay, so here it came from or by lightning or by the sunlight. Okay, as the high temperature and the light, it can make this reaction or give or provide the proper condition for the reaction to produce the NO2 or NO, which is nitrogen oxide or nitrogen dioxide, and this is called lightning forms. But the man-made one, which we can find it under very high temperature and very high pressure, this is a man-made vehicle exhausts and combustion in fuels, the combustion of fuels releasing NOx. So here by lightning, okay, and here by under heat and pressure to produce NOx. NOx here, the number of oxygen, and this is a pollutant gas came from vehicles and other motors. Write an equation to describe the role of NO2 in the direct formation of acid rain. Of course, NO2 is the main reason for, or one of the main reasons for acid rain, and the equation of this acid rain forming is 2NO2, as we know, plus H2O from the rain should gives us nitric acid, HNO3, plus nitrous acid, which is HNO2. Okay, explanation here to explain that NO2 reacts with water to form nitric acid, okay, which is HNO3, and the nitrous acid, HNO2, contributing to acid rain. The next question is peroxyacetyl nitrate, which is PAN, is a compound of photochemical smog. Smog here, it came from smoking and the fumes with water in the same time. Describe how PAN forms from NO2. We know this reaction well. It came from the reaction of nitrogen oxide with VOCs. What's VOCs? Is volatile organic compound like aldehyde or ketones. Okay, so NO2, if it reacted with NO2, this compound or this nitrogen oxide, if it reacted with volatile compound, the organic compound VOC, okay, is volatile organic compound, they will give us PAN. So the reaction of nitrogen oxide with volatile organic compounds. Okay, this reaction to produce what? Peroxynitrate or peroxyacetyl nitrate, which is PAN. Peroxyacetyl nitrate. PAN. Perfect. The question is, nitric acid reacts with basic oxides to form nitrates. Like what? Write an equation for the reaction of nitric acid with calcium oxide. What is nitric acid first? Nitric acid is HNO3. If it reacted with calcium oxide, which is CaO, okay, it will produce what? How many nitric acid should react with CaO? As we know, Ca, it will react with NO3. Ca is positive, how many? Positive 2, and NO3 is negative 1. So Ca, it will react with how many nitrate? 2. It will be CaNO3 in practice and 2. So we should use here 2HNO3 to give us CaNO3 plus H2O. Okay, this is the reaction of calcium oxide, which is a basic oxide, neutralizes nitric acid to form calcium nitrate. This is salt and water, and this reaction we consider it as a neutralization reaction between basic oxide and nitric acid. The question is, describe what is seen when solid calcium nitrate is heated strongly. Okay, calcium nitrate is a compound or a salt. If we heat it strongly, it can produce calcium oxide, nitrogen oxide, and oxygen. Okay, and here the nitrogen oxide, as we know, it's a brown gas or brown fumes. So the main detection here, or the main point here, nitrogen oxide is a brown fumes. To write the equation is CaNO3. Okay, this is the equation. If we heat it very well, it can produce what? CaO, calcium oxide, plus what? Plus NO2 plus O2. Okay, now this gas or this oxygen gas is, yeah, it's colorless, but NO2 is brown fumes, brown fumes or brown gas, which is NO2. This question on strong heating calcium nitrate decomposes to give us the nitrogen gas, and the nitrogen gas we can detect it by its color. To make our balancing for this equation, we should use 2 of calcium nitrate to produce 2 calcium oxide and 4 NO2 in presence of 1 oxygen mole, not just 1. That's why we added 2 here and another 2 here to make our balance. The question is, a common test for nitrate is the reaction with NOH, and equation 1 shows the reaction. The equation is 3NO3 plus 8 aluminum, okay, plus OH. Question B. A common test for nitrates is the reaction with sodium hydroxide and aluminum. The equation here shows us this reaction. Equation is 3NO3 minus plus aluminum plus OH plus H2O will give us 3H3 plus aluminum hydroxide. The first point, deduce the oxidation state for nitrogen in NO3. Okay, what is the oxidation state here? How can we detect it? If we have something like that, NO3 composed of nitrogen and oxygen. Okay, NO3. And here we have our detector, which is oxygen. And we know this oxygen, actually oxygen, it has oxidation number, how many? -2. How many oxygen do we have? 3. So 3 multiplied by -2 equal -6. Okay, and the total oxidation number for our ion is -1. -6, to remove -1 from it, it's equal what? It will be, because here we have -1, so the total oxidation number for oxygen, it should be -6, and here we have -1 for the total oxidation number of ion, so it's -5. So nitrogen here, it should be +5. So the oxidation number for nitrogen here is +5. Identify the species that got oxidized in equation number 1. Which one got oxidized? Oxidized here, it means oxidation number got increased. As we see here, what happened for aluminum? Aluminum, it was 0, okay, and converted to be +3. So aluminum from 0 to be aluminum +3 in aluminum hydroxide got oxidized. Okay, which element got reduced? Because we have here redox reaction. If something got oxidized, the other one should get reduced. So here, look for nitrogen. Nitrogen, we said it was +5 and converted to NH3, and we know NH3 here is -3. So from +5 to -3, the nitrogen got reduced and aluminum oxidized. NH3 is a basic gas, of course. Describe how NH3 is able to act as base. We know well nitrogen, if it reacted with 3 hydrogen like that, it still here has lone pair of electron. This lone pair of electron, its density of electrons, it's able to accept proton from acidic compound. So it's a base. So why NH3 is basic? Because it has, or the nitrogen has, lone pair of electrons able to accept proton, H positive. Okay, the question is, suggest the shape of aluminum hydroxide. Okay, what's the shape of aluminum oxide? This is a kind of a complex, and this four ligands of hydroxide ions, hydroxide groups. So aluminum here reacted with 4 OH groups to give us tetrahedral shape. Are they 4 like that? Tetrahedral shape.